Well, hello guys, and welcome back to Mr. G Physics. Here's Mr. G, and today we're going to be doing a video for the grade 12. It's related to momentum, changing momentum. That is the first topic that you should be doing at school. It's an important concept that is a way of getting or scoring a lot of mark for the examination. But before we start with the video, don't forget to subscribe for the channel and thumb up the video so you can get all notifications on videos I post on regular basis. Well, as I said, we're going to start looking at momentum and impulse. The first lesson is going to be just momentum and the change in momentum. It is quite important, and by the end of this video, guys, you should be able to know what is the definition of momentum, as well as you should be able to explain what is momentum, what is change in momentum, and obviously you're supposed to be able to illustrate momentum, change in momentum, final momentum, initial momentum, which could be a little bit tricky, but we're going to make it as simple as possible. Let's begin with the definition of momentum. Now, momentum is one of the easiest definitions you are going to have in grade 12 perhaps, which is the product of mass and velocity. Now, the symbol for momentum is going to be small p. This one here is the symbol for momentum. And yes, that vector symbol on top, it means that this is a vector. We're going to speak about that one in detail just now. It is a vector, and that is the symbol for momentum. All right. Now, according to the formula, is a product. According to the definition, is a product of mass and velocity. So we can say that momentum, the formula will be equal to the product of mass and velocity of an object. That is the definition of momentum, and that is, guys, the formula for momentum. It is going to be given to you in the exams. The vector notation is not important at the moment. You are not going to be penalized, or you won't lose marks if you don't use the symbol notation for a vector quantity. We'll speak about vectors just in a moment, but let's first of all break this one a little bit more. We have here that P is momentum, so let's write here momentum. Momentum is symbol is P. And guys, let's go to the unit. But before we look at the unit of momentum, let's look at mass. So now we have mass. Now the unit for mass, and I'm speaking about the SI unit, the International System of Units, that is going to be the kilograms. So the unit for mass is going to be the kilograms. You know that we've been using mass for different physical quantities before. The second physical quantity here is velocity. Note that velocity is also a vector quantity. The unit for velocity is the meters per second. That is the unity of the unit for velocity. Remember, velocity is also a vector quantity. Let's write it here. It's a vector quantity. It therefore has magnitude and direction. As I said, we'll speak about vectors just in a minute. So if we look here, what we have, momentum is product of mass and velocity. It is therefore, in terms of unit, will be the product of kilograms multiplied by meters per second. Guys, this is the unit that we are going to use for momentum. So this is everything that you should know about momentum in terms of definition, formula, symbol, and unit. It's very important, and it's quite simple, really, really simple. So now let's go to see how do we represent vector. First of all, it's a vector quantity, as we just mentioned. Therefore, the symbol, the correct way of doing it, is that P, which is the symbol for momentum, with a small arrow on top. That should be the correct way of representing momentum. However, at the moment, you are not going to be penalized for that symbol. But because it's a vector, we also need to draw vectors. And let me just maybe make a vector here. That is a vector that represents the momentum of an object. For instance, let's say that one is the momentum of a certain object. We use a vector which is a straight line with head. That is a vector. Now, something important. Remember the formula, which I am going to rewrite here. Rewrite the formula every time you have an opportunity, because you will memorize it. you can see that momentum depend on mass, and momentum also depend on velocity. So there are two physical quantities from which momentum will depend on. It means if two objects are moving, for instance, with the same velocity, the object with a greater mass will have a greater momentum, and other way around. If you have two objects that are moving and the mass of the both objects is the same, then the object that have a greater mass will have a greater momentum in terms of velocity as well. Greater velocity, greater momentum, I think is here is quite simple and is related to mass and velocity. All right, so now we go to see one little simple example. This example says calculate the momentum of a car of 1,000 kilograms that moves at 60 kilometers per hour to the right. So now here, before we start, guys, I always recommend the children or the learners to write the data, what is given to you. In this case, it's quite simple. The mass is equal to 1,000 kilometers, and we have that the velocity is equal to 60 kilometers per hour. No second, hour. Now, before we move on, we are going to select the direction as positive. In this case, it's only moving to the right, so it's quite simple, but we are going to write it still. So I highly recommend you to write it like right is going to be positive. Write it, and if it's not too difficult for you all, then highlight it so you can see it every time. It means that that velocity is going to be positive. So as part of the data, I select the positive direction. However, we cannot work in kilometers per hour. We just mentioned previously when we went to the formula right here, right? That is the SI unit. So we have, let me erase that line that just appeared there, we have to convert. Now, how to convert from kilometers per hour to meters per second? Now, from kilometers, and I'm going to leave that note here, from kilometers per hour to meters per second, you have to multiply by 1,000 and you divide by 3,600. Guys, this one is very, very important. Keep it because many times you're going to be giving the data in kilometers per hour. So it's no good we have to convert. So let me just get my calculator, which is here, and then let's convert this one. But I'm going to write it so you can see this is equal to 60 times 1,000 divided by 3,600. All right, and this one, guys, is going to be equal to, let me just do it, 16 times 1,000 divided by 3,600. You get that is 16,67 meters per second. I'm not going to write to the right. I am rather going to write a positive at the front because it will be easier at the time of substituting. As I say, this one is very easy. It's only one motion, it's only one object, but it is quite important. So now from here, guys, we are looking for the momentum. So as part of the data, you may, if you want, write that momentum is question mark. So let's write it here. This is question mark. Formula is quite simple. Momentum is equal to the product of mass and velocity. I am, as a teacher, going to use the vector symbol, but you don't have to. So momentum is equal to the product of mass, which is 1,000, multiplied by 16,67, and that will give me, this one is 1,000 plus 16,67. Guys, I get that is 8. I don't suppose to add 1,000 times 16,67. I'll get that is 16,000. Momentum is equal to 16,670 unit kilograms meters per second. And now, guys, the direction is a momentum. It have direction. So the direction is going to be, it's a positive answer. It means it's to the right. That is the final answer for this simple example. I hope it helped. So the next definition we're going to speak about is about changing momentum. Guys, if the velocity of an object change, it means that the momentum will also change. Velocity can change in terms of magnitude or in terms of direction even. So now, what we're going to speak. First of all, guys, remember that in physics, delta means change. All right, and change is always going to be final minus initial. For instance, we have a picture there or drawing of a man kicking a ball. That ball was moving towards that person, and that person kicked it in the opposite direction. So the momentum of that ball changes. All right. So now, how do we calculate the change in momentum, guys? Change in momentum. Let me just fix this one. Change in momentum is equal to final momentum minus initial momentum. I am going to keep the vector notation, guys. Okay. So now, if we substitute the definition of momentum, we have that the change in momentum is equal to mass multiplied by the final velocity of that object minus mass multiplied by the initial velocity of that object. We're speaking about certain object, one object. Therefore, the mass is the same. So we can use the common factor. So we can say that the change in momentum is equal to mass as a common factor, bracket final velocity minus initial velocity. It is really simple. As a teacher, I'm going to keep the vector notation, but I'm going to emphasize that at the moment is not needed for marks. Guys, this is terms that this change in momentum is quite simple. Now, we're going to look at one example. This could be a little bit more tricky than the previous example, so let's see what is happening here. Now, I say a ball of 0.5 kilogram moving at 10 meters per second. I kept the symbol of meters per second in that way because it was tricky to type it in another way, but it's the same. Towards a player is kicked backward. So a ball is coming and the soccer player, whatever the ball is the case, kick that ball in the opposite direction. Calculate the change in momentum of the ball, and then, very important, use a vector diagram to represent the initial momentum, final momentum, and change in momentum. Very simple. First, let's keep doing the same. So let's extract the data here and let's do it fast. Data. Now, we have that this ball changing direction. We have a forward direction or towards and backward. So it's entirely up to you what direction you want. For the sake of this example, let's write towards as positive. That is very important. I'm going to highlight it even, guys. Toward is positive. It means that everything that is towards is positive and everything that is in the opposite direction is going to be negative. So the mass of the soccer ball is equal to 0.5 kilograms, and now we have initial velocity and we have a final velocity. All right, the initial velocity is 10 meters per second towards, it means it is positive. And I'm going to change the symbol. I'm going to write meters per second in the way we do it here, guys. And then when that person kick the ball, is going to move in the opposite direction. So this one is negative 20 meters per second. We're looking for the change in momentum. That is the question mark here. So we're using the formulas that I just showed you. You have that the change in momentum, you don't have to write all of them. You can say the change in momentum is equal to the product of mass, bracket final velocity minus initial velocity. And then you substitute. So nothing to say, is quite simple, but here is the part where you have to be very careful with the direction, or else you will lose all the marks. So the mass is going to be 0.5 bracket. Final velocity, guys, is negative. Look here, it's negative because it's in the opposite direction, and I select the forward direction as positive. So this is minus 20. Let me just use the same color. I don't want to now change that color. Minus 20 minus initial velocity, which is positive 10. So it's minus 10. Guys, this is the substitution. So change in momentum is going to be equal to, and then the calculation, let me do it here. This is 0.5. When I type in the calculator, I type exactly in the same way as I have the substitution, so I don't make mistakes. So it's minus 20 minus 10, and then I'll get that this one is minus 15. So minus 15 kilogram meters per second. Now, I want to emphasize in something. That minus means away, guys, but I don't know. I feel more comfortable if you write it in word, because I think that sometimes they don't want to give marks, at least you write inward. So the final answer, we're going to do the following. For the final answer, I'm going to do it down here. We say that the change in momentum, I'm going to keep the vector all the time, you don't have to, is 15 kilogram meters per second in the opposite direction. So you can say backward, for example, which is written in the question. Backward. And that is the correct question. I hope it's clear. Now to finish, let's do the vector diagram. Now, for the vector diagram, we are going to do the following. It's tricky because this is a subtraction actually. It's not an addition, or it's an addition of a negative vector. So the best and easiest way to do is to draw the initial and the final momentum starting from the very same point, not matter what the direction is. For instance, let's say forward is to the right. So the initial momentum will be this vector that is, oh my goodness, this vector that is to the right. That means forward. This one is the initial momentum. Now I am going to draw the final momentum, and I am going to start from the tail of the first vector, guys. So from here, I'm going to start in the opposite direction, which is now, if you keep the length of the vector as a reference, the initial would be like half the final according to the data, because the velocity is double. So this one is obviously a longer vector, and we started from the same point always. This one is the final momentum, which is started from there, and we have now already drawn the initial and the final. Note, I am using this method to represent this change in momentum. So the change in momentum will always be from the head of the initial momentum to the head of the final momentum. In other words, the change in momentum is this vector that is going in that direction. Guys, remember to use a ruler, and I'm sorry for me not to use a ruler here. So this one here is the change in momentum. It's quite simple. Saying it again, you always start with both of the vectors at the same point, in other words, at each tail. So there is the starting point for them. You keep the direction of momentum as they are given to you in the question. And the change in momentum is always going to be from the head of initial momentum to the head of final momentum. Guys, this is all for this video. I hope it helped. If it helped, please thumb up, subscribe for the channel, share the video. I will be releasing quite soon a lesson plan with all the lessons about momentum, and I already done a material for consolidation of the topic, which is also going to be out very soon. Thank you for watching. Thumb up. I'll see you next time.